In this video, we'll be finding a maximum or a minimum over an interval. We'll actually find the maximum and the minimum over a single interval. Now, what do I mean by that? Now, I've got a cubic function here, x cubed plus 1.5x squared minus 36x. Now, it's the same cubic function that we've already dealt with, so we know pretty much what it looks like. Now, I want to know what is the maximum and what is the minimum over this interval. -7 is less than x, which is less than 1. Now, we know that this function is a cubic function, and we are only considering this cubic function over this interval, -7 to 1. So we need to know what the highest y value is and what the lowest y value is over those points. Now, obviously, we're going to need to see pretty much what this thing looks like. One of the things that we need to know is the turning point. Now, we've done it before, but I'll quickly go through it again. Turning point, f dash x, that's going to give us 3x squared plus 3x minus 36. Now, to find the turning point, you let the derivative equal 0. 0 equals 3x squared plus 3x minus 36. And when you solve that using GC, we get a turning point where x equals, what was it again? X equals -4 and x equals 3. Now, you'll also recall, hopefully, from the last video, that we determined the nature of the turning points. Now, I'm not going to do it in this video because we've already done it. Determine nature of turning point. Now, in this particular video, when we only need to determine the nature of one of them, because x equals 3, this one here, we can disregard. Now, why can we disregard it? Because it doesn't fall within our bounds. Remember, we're only dealing with maximums and minimums between -7 and 1. So they're the only things we're interested in. X equals 3 falls in this area somewhere, whereas x equals -4 falls smack bang in here. Now, you'll remember that we determined the nature by subbing -4 into the second derivative, and we figured it out that it was a max. Okay. Now, we've solved the second derivative, blah, 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 blah. Therefore, -4 is a max. Now, if -4 is a local max, and it's the only local max within this area, that means that it's going to be the max over the interval altogether. So we just need to figure out what the coordinates of that are. So we can sub -4 back into our original equation to find out where our turning point is. Sub -4 into f of x. So that'll give us f of x equals -4 cubed plus 1.5 times -4 squared minus 36 times -4. Now, obviously, you're going to use your calculator for this, and when you type all that into your calculator, you should get 104. Now, you can also use your calculator graphically, use your graphing thing to find the max as well. Use your trace function, use your gsolve, use whatever you want to do, and you'll find that that's 104. Okay, so now we're starting to get a bit of a shape of what this looks like. We know that it has a turning point at -4, and that turning point is 104. So we've solved half of the problem. Put up half of my answer here. Max at -4, 104. Sorry, that should be a 4. Now, our minimum is more complicated because our minimum could exist in 2 points. It could exist here. Sorry, let's do that again. It could exist on this line somewhere, or it could exist along here somewhere. The only way that we can really figure it out is by testing both. Okay, so test for minimum. Sub -7 and 1 into f of x. Okay, so basically we're going to do the same thing that we did there. Instead of subbing -4 in though, we're going to sub -7 and 1 in. So let's try that. F of -7 equals, and f of -1 equals. Now I'm not going to write it all out, you're just doing the exact same thing we did here, just -7s instead of -1s. Sorry, my bad there guys, not -1, it should be 1. Okay, so is -7 our local minimum, or is -1 our local minimum? Now put that into my calculator and I've got two answers. For -7, I've got -17.5. So where I circled is about where it is, somewhere around here somewhere. That's -17.5. And for F1, I get 33.5, which is, sorry guys, keep missing my negatives, -33.5, which is around about here somewhere. Now that means that this part of our function looks something like this. And obviously -33.5 is lower than -17.5. So our local minimum between -7 and 1, our minimum is at 1, -33.5. Okay, so it looks like there's a lot of work there, but there's really not a whole bunch to it. Basically, you're taking a function and you're finding the maximum between two numbers, and you're finding the minimum between two numbers. One of them will probably be a turning point. The other one will probably be at the boundaries, either at -7 or 1. We might throw something in there where they're both turning points, but that's actually easier because you just need to do the double derivative twice to find each turning point. Okay, so that's finding a maximum or a minimum over an interval. Using the double derivative to find the nature of a point, and then checking the boundaries to see which one is either a minimum or a maximum. Alright.